Welcome to iOS 9, iPhone, and iPad app development. This is lesson 5, the What If app. In this lesson, we're going to first and foremost make an app, our What If app. We're going to understand and navigate Xcode. We're going to understand the app creation process. We're going to create a new class file and associate it with a view. We're going to understand the UI elements that are available to use in Xcode. We're going to use an array as a data source and randomly select an entry to display. We're going to connect UI elements to the code view. We're going to make a sound class file so that our app can play sound. And we're also going to make it so that we can shake the phone and have the same effect as pressing a button. So pretty cool stuff coming up. Let's take a look at the app. Basically what it's going to do is it's going to play a sound, which I have disabled just for the time being, and it's going to change this text here to a question. So let's try it out. So it says, what if you could commit one crime without being caught? What would it be? And if we press what if again, we'll get different answers, or questions rather. So it's a pretty neat app. It's very simple and concise. As I said, it's going to play a sound. It obviously generates a random question out of an array. And we're going to tackle this right now. But first, I just want to go through Xcode real briefly, just to make sure we're familiar with the areas that we need to be familiar with. And we'll take it from there. So let's get going. Okay, so we're going to start making our What If app, but before we do that, we should familiarize ourselves with Xcode a little bit. So for some of you, this may be the first time you've opened Xcode and started a project, but that's exactly what we're going to do. We're just going to create a dummy project, so to speak, and we're going to see what can be done in Xcode, see how you navigate around and whatnot, and we'll just be a little tour of Xcode. So let's get into Xcode and see what's up. Okay, so when we first open Xcode, we get their welcome screen, as you know, and we can start a playground, a project, or open another project. And in this case, we're going to start a project. But before you do that, you should have an area on your hard drive that you know where you're going to keep your projects located. So we're going to click Create a New Project. And I'm just going to move this into my view area here. And we're going to create a single view application. So iOS, make sure you select iOS application and then single view application, and we're going to click next. And I'm just going to call this intro. Now the organization name, that could be your name or it could be the company you're working for. Organization identifier is generally a reverse domain name. So my domain name is xpsjson.com, so I would just write that backwards, com.xpsjson. If you don't have a domain, that's okay. Just use something like edu.yourname. Make sure for this entire course, we're going to be selecting the language Swift, and we're going to select Universal for devices. And in this case, we're not going to use core data or any of the unit testing, so just click Next. Then it's going to ask you for somewhere to save it. This is exactly actually where I want to save it. So I'm just going to click Create. And don't bother with a Git repository right now. Just go ahead and click Create. And this is the first screen you see when you come into Xcode in a new project. And this is pretty much where people get overwhelmed because there's so much information here. But we're going to go through this step by step. Basically, you have the bundle identifier, which is based on what you entered in the previous screen. And then you have your version and build. And when you're starting a project, you don't need to worry about that. If you update a project, then you would want to change your build number or your version number, depending on how significant the changes were. The team here is just your developer account. So select your developer account there. And then all this information here, deployment target, it's automatically set for 9, which is fine. Devices, it goes off of your selection, so universal. The main interface is usually always main, so just keep it as main. Now, device orientation, this is how you're going to allow people to interact with your app. So in the case of, the what if app, for example, we're only going to do portrait and upside down. Now, this isn't the what if app project yet, but just to give you an example. Status bar, I always leave default. Now app icon source, leave app icon. And the launch screen file, you have a decision to make. You could use a launch screen, or you could use the main storyboard. I'm going to use the main storyboard for this one because it's really not a project. When we get to the actual app that we're going to make, we'll use a launch screen. This way I can show you what a launch screen is. And then linked frameworks and libraries, embedded binaries, don't worry about this. Now this is only the one tab. There's all these other tabs up here. And it's kind of information overload. Everything up here, aside from general, just imagine wasn't there, because you don't really need to know about it yet. What we want to focus on now at this point is getting our app started, but I want to show you a couple things. And one is that we're selecting this intro over here on the left, and that brings us to this screen. Okay, so this is our folder organizer, or whatever you want to think of it as. But basically that's by clicking this little folder icon, we come up with our menu of folders, our folder hierarchy, so to speak. And this is what we're left with. So let me explain these files a little bit. Basically, your app delegate controls the entire app. And for the most part, we don't mess with the app delegate. We will mess with the app delegate a couple times throughout this course. But for the most part, you can leave the app delegate as is. Now, the view controller and the main storyboard are very important, and they're actually connected to each other, but I want to show you the main storyboard first. So if we go into the main storyboard, first you'll see I have this controller scene, which is a hierarchy again. And this is a hierarchy of what's on this storyboard, basically. But we can press this little icon so we have more room. So you'll see this is where we actually go ahead and design our app. So this is a view controller, and it's basically a view of what the user is going to see. So remember, we're in the main storyboard. So if we double click here, you can see that we only have one view controller. And this little arrow indicates that this is going to be the initial view controller when the app runs. Okay? So if I double click, I'll get back into the area where I could add things to this. But before we start adding things, I want to show you that this actual controller here, if we select where it says view controller and we come over to the third section, you'll see that the class file associated with that is view controller. And that means that this actual scene, or view as I call it, is connected to this view controller. So if we click into this view controller, this is the code version of that view. So in other words, these are tied together. So we're able to take elements that are on this view and connect them to the code in this view controller. Okay, so, and I'm going to explain that in a second, but I want to move back over to the overall scheme of Xcode, and I want to show you this top section. First of all, before I get there, this has 6 sections, and don't worry about all 6 sections right now, because they they're kind of context interactive. Whereas you'll be brought to this section or this section when you need to. And when you don't need to, you can come back here to the file inspector. So at the top of the screen, there's this play button, and that will let you build the actual application that you're running. But before you do that, you need to select a simulator, and you do that here. So we're going to select an iPhone 6. And I'm going to play this even though we haven't coded anything into it, just so you can see, and I suggest you do the same thing. So you can see the simulator in action. It's always a good idea to get the simulator running, because the first time the simulator runs, it takes quite a while to load. And after it loads, then it's a little quicker. So here's my simulator. And if yours came up on your screen and it filled your screen, or reversely, it's too small, then while you're in the simulator, select the Window menu item and then Scale, and select something appropriate for your screen. So mine is at 50%, and that's pretty good right now. So now I'm just going to stop this. You'll see there's nothing here because we haven't added anything. So I'm just going to stop this, and we're going to move across here. So this here basically is like the iTunes status message. So it tells you what's going on. So we just finished running intro, which is what we named our app, on an iPhone 6. And then these three buttons here are all kind of interlinked. This is the button that shows that we're just looking at a standard editor. This would be a dual view editor, or an assistant editor as they call it. And this section here is a version editor, which we don't use all that often. Now the nice thing about Swift, or not Swift, but the nice thing about Xcode is that it can accommodate your screen space. So if I'm working on this view, let's say I was in the view controller and I really need to concentrate on the code, these sections here allow me to shut down the left side and the right side if needed, and bring the right side and left side back, as well as the console area at the bottom, which will pop up from time to time if you have print messages or things like that. So what I want to do is move back now to the main storyboard, and I'll show you some of the interface elements and what we can do with the main storyboard here. So as we look at this blank canvas, this is basically where we paint our user interface, and this is where we get our items from, this bottom section. Now this can be moved up or down, but it doesn't really need to be that big because you can always search for what you need. But basically, if we needed to add another view controller scene on here, we could bring that in and drop that on there, and then we could line that up. And if I double click and come out a little bit, you'll see now I have two view controllers on here. Now I don't have any way to get from this one to this one at this point, and we're not going to deal with that at this point. I'm just showing you that that can be done. I'm just going to delete that out of there. So we're back to one view, and you can make storyboard references. We could put navigation controllers, table view controllers. All these yellow ones are different types of controllers basically. And then once you get past that, then you get to the actual interface elements like labels. So what I'm going to do is I'm just going to bring this into the scene, and you may be wondering why we're dealing with a square canvas when none of the iPads and none of the iPhones are square. And the reason for that is we build it into a square grid basically, and we use what's called auto layout. So as I'm dragging this label in, you'll see these blue lines appear, and always be aware of those blue lines, because those are what help us lay out our items. So you see I went all the way from the left to all the way to the right on this label, even though I'm just going to center it. So if I go into the fourth section, I'll be able to mess with the attributes of this label. So I'm going to center the label. I'm going to change from our default font, and I'm going to go to like an ultralight, and I'm going to make that bigger. So I'm going to go to about 42, 48, and just drag this so we can see the whole thing. And I'm just going to name this intro. Okay, so now we have a label that says intro on there. And if we want, we could take a button in there. We could put segmented controls, text inputs. So what I'm going to do in this case is I'm just going to drag another, I'm going to drag a text field in here. So somewhere for people to put text. And I'm just going to put that right where that blue line appears under intro. And I'm going to bring that all the way across again. So there, now we have a text field. So then next, if someone puts a text in there, let's say we want a button, so we'll drag a button in there. And I'm just going to move that over slightly. And I'm just going to make this say enter. And I'm going to change the background on that button a little bit so that we can actually see that it's a button. So this is going to do a light gray. Okay. So with that done, what we can do is we can add another label here. So I'll add a label just right under this. And I'm going to drag it all the way across. And for this little section, because I want to show you how to connect the code and everything, I want to show you how we do that. So with this view controller selected, we want to go into dual view. So we click that icon, and now you'll see that what we're on is the main storyboard over here, and we're on the view controller that's associated with that storyboard on the right hand side. Now this will probably flip you out a little bit if you're coming from other programming languages, but if we want to make a reference to this text field, we hold down Control and we drag it right into the code, and we're just going to call that text field 1 and connect that. And now we have a reference to that text field. Now we also need a reference to the label, so I'm just going to make one line of space and we'll just bring this label in. So we'll Control drag that in and we'll just call that label. And now we have a UI label and a UI text field. Now this is just me. It's a just a coding practice that I do, is when I bring in buttons or methods or functions, things like that. Like this is going to be a function because we need it to do something. So I'm going to say enter tapped as a name for that and connect that. And I messed up, so immediately I can hit Control Z to undo that connection. Now this is a common error that a lot of people do, whereas I wanted to bring this in as an action so that I can make it a function, and I accidentally brought it in as a button. So I hit Control Z. Now if I right click this, I can see that there's no outlets active. So I did that properly. That means I can delete this. But I want to show you how to do this the wrong way again and show you how to fix it, because it's a very common error. Bring this in. Now I want to bring it in as a text field. I want to bring it in as a action, technically, but I'm going to accidentally bring it in as an outlet and connect it. And I'm not going to hit Control Z. I'm going to do something else. Now if I right click this, you'll see that this has a referencing outlet going to the view controller, and it's a label which we don't want. So we can't just go ahead and delete this because that will still be there. See that? We have to X that out here also. Okay? And now we're able to bring this in as an action as we wanted to. So again, we're just going to call it enter tapped. But this time, we're going to make sure that we bring it in as an action. And if we hit connect, you'll see now we have a function here that we can code. So what we're going to do is I'm going to get rid of this right side. And all I'm going to do in this function is I'm going to go ahead and set that label text. So I'm going to say label dot text is equal to and we'll go ahead and take our text field dot text when we go ahead and update that. So let's give this a run and see what it looks like. And before I do that, I just want to click this one little thing, and you might not be able to see it. If we click into the view and we click this and all the way towards the bottom, I just want to hit reset to suggested constraints, and now I'll run this. So basically whatever we type in into that text field, when we hit enter, it should appear on our label. So we'll just wait for our simulator to come up. And if I type in hello here and hit enter, and there it is, hello there. So let me stop this. This is just a basic introduction to Xcode, and as we go along through the course you'll learn more about Xcode, but this should help you get by for our first section at least. So we're going to wrap it up here, and next we're going to talk about the app creation process, and then we're going to actually make our what if app. Alright, so I'll see you in the next video. Okay, in this video we're going to talk a little bit about the app creation process, which basically goes concept, design, and then code. So the first thing that you want to do as you think of an app is you want to put it down on paper, and we'll go through the steps, which are kind of you know, you don't have to follow them step by step, but it's a good idea to do it this way. This way you don't miss any features or anything like that as you're going. Okay, so let's take a look. So as I said, put it down on paper. I meant that quite literally. I have an idea for an app called What If, and all it's going to do is it's going to display a random question. When you press a button, it's going to give you that random question. I think we'll probably allow the user to shake it to get that random question, and then it'll make a noise when we shake it. So the features are that it displays a random message when you go ahead and press or shake it. So that should be written down somewhere, probably right next to our little sketch. Okay, so we don't forget any of those. All right. Now, the next thing you do is first you make this sketch, which is very, very rough. And then, still rough, you want to go into Xcode and design your basic user interface. But don't play with it so much that you become overwhelmed with trying to get it designed perfectly, because most and foremost, you need to get it coded correctly. So you want to get a basic idea of what it's going to look like, code it, and then tweak how it looks when you're done. Okay, so basically that's it. And then with this, from this, we get this. So that's, you know, our app from concept to design to production. Okay, and really, if you follow that format, then you can have all the great ideas that you want and still retain them, because a lot of people have great ideas for apps, but then they forget about them, and you know, they never get around to making them. So if you put it down on paper, then one day when you're bored, you can go ahead and make that app that you thought about, you know, 4 or 5 weeks ago. You know what I mean? So always keep it, you know, in the back of your mind that when you have an idea for an app, even if it seems kind of silly, to put it on paper, because you can tweak that app idea and make it into something that is actually pretty special probably. So with that in mind, we're going to move on, and we're going to actually make this what if app from this sketch. We're going to make it into this. Okay, so let's do that. So we're going to start building our app now. So we're going to get into Xcode and start a new project. And before we actually get into coding and designing our app, I want to touch on making sure that the code is connected to the UI view, because if you think about it, every view controller or every view will have a view controller typically. So you want to make sure that it's connected to the right view controller. The right view is connected to the right view controller. This way you don't have any problems with the code not running because it's not attached. Okay, so we're going to take a look at how to handle that right now. So here we are in Xcode, and we're going to start out by creating a new Xcode project. And it's going to be a single view iOS application. So go ahead and select that and click Next. And I'm going to name this What If. And again, the settings that you put for your last application should be fine. We're not going to use core data or do any unit testing. Make sure you select Swift and Universal as device and click Next and save that where you want to save it. Don't create a Git repository, just click Create. Now, what I wanted to show you was on this main storyboard here that this view controller, I'm going to get rid of this side so we can see it a little clearly. This view controller here, if we look at the third section on the right, is connected to a class called view controller. And now that's really critically important because any UI elements we have in here, we need to connect to that specific view controller. So it should go without saying that view controller, which is this file here, which is of the type UI view controller, is just a terrible name for a view controller, because if you imagine that every view needs a view controller, then view controller 1, 2, and 3 aren't really typically what you want. So the important part is that it says view controller here in quite a few places, but the important spot is where the class is declared right here. So I don't particularly like the name view controller, so I'm going to change this to main VC for view controller. And that is actually the only place I need to update it, but it doesn't make any sense to have it called view controller over here. If it's main VC is the actual class, they should always match. So I'm just going to change this to main VC and hit enter to tag that in. Now this part here is just in as a comment, but I'm going to change that as well. So this will have really no bearing on it, but I changed that as well. Now the important part is when we go back to the storyboard and we look at this, this is still associated with the class view controller. But if we drop down, we can select our main VC. And once it's selected as main VC, then the code is tied together. And one other thing I want to show you is if we didn't have this view controller at all, so if I went and deleted this view controller, and I'm going to move it to the trash, then we have no view to associate this with. We have no view controller to associate this with. Main VC doesn't exist anymore. We have all these things here, but they don't really exist yet. So we need to create a file. So in our what if folder, we right click and hit new file. And what we need is an iOS source Cocoa Touch class, and click Next. And we want to make that a subclass of a UI view controller. Now, capitalization is generally a standard here, and I'm just going to name this main VC. Make sure it's Swift, and I'm going to just click Next and save it right where it wants to go. And you'll see that brings it right here. I'm just going to slide it up under our main storyboard. And we go back to our main storyboard. Now this is technically already associated with main VC, but just make sure that it is. And we're ready to get started. So what we're going to do in the next video is we're going to add our interface elements to this to begin our what if app. Alright, so I'll see you in the next video. So in this video we're going to start designing our what if app. And we're going to take a look at how to add these interface elements and get them lined up properly. And we're going to use Xcode's auto layout in order to do that. So let's jump back into Xcode and get this done. So we're going to start adding our interface elements now. And the first thing we want to do is bring in a label. So we could scroll down or we could just search for label. There it is. And we'll just bring that in. And I'm going to use the blue lines to line this up. go all the way to the left there, and then slide this all the way to the right to this margin. That's a margin. Okay, and then I'm going to go to the fourth section here so we can design this a little bit. So I'm just going to center the text, and I'm going to leave it as a system font, but I'm going to change it to ultralight and make it nice and big like we did last time. So this is going to say what if, and I'm just going to make it like 52, and we'll just drag this down so we can see the entire thing, and we'll make this say what if. Just a basic label. But we're going to do a couple things to it. The first thing I want to do actually is make it white, because we're going to have a background on it. But before I do that, what I want to do is add a shadow to it. So if we come down, you'll see our shadow color here, and we'll make that black. And then I'm going to make horizontal and vertical both 2. And now if we go ahead, I just realized I don't want ultralight, I just want thin. So now if we go ahead and make this white, we can still see it. And also we're going to use the same type of a font for our middle section. But before we do the middle section, I want to add the button. So we'll just search for a button here. And this is the button we want, just a regular button. And I'm just going to make this a little bit bigger, to the left and the right a little bit. And then make sure that hits our center line. And we'll just say this is what if also. And enter that there. We want to bring in one more label now. So there's our label, and we'll just drag that into the center here. Now I want to show you how to align this, but I'm going to show you how to align it with auto layout. But we want the height actually to go all the way up to where this starts and come all the way down to where the button starts. And for the width, we're going to do the same thing. We're going to go over to the margin on the right hand side and to the margin on the left hand side. Okay, now let's center this, and we'll make this a nice font also. So we'll go with ultralight on this one. I'll do about 32, 38, and just say done on that. And we're going to do the same thing. We're going to do that shadowing again. So we're going to make it black, and I'm going to do 2 and 2. And I'm going to make this white. Okay, so basically, because we're going to have a background, and the background might show up better with it white, or it might show up better with it black. I'm not too sure yet. But on this what if button here, let's just change the background color to black and the text color to white. So we're going to scroll down to get to our background color. There we go. Now we're ready to add an image. So I need to tell you how the images are added. All your images go into this folder called assets.exe assets. And you see there's already an item here for an app icon. And that can take several images because there's several resolutions that we need our app icon to be at. Okay, so that's important to realize. But we want to add another image. So I'm just going to right click here and click new image set. And I'm just going to call this BG for background. So we need to just click in there so we can rename it. And now we're ready to drag our background image in. Now I have a blue background image, and I'm going to drop that on the 1x spot. Now it's important to note that Apple seems to be moving away from using 1x. So in other words, this is 1 times the resolution. This would be twice the resolution, 3 times the resolution. So for something like a iPhone 4, something like an iPhone 6, and then something like a 6 Plus or an iPad would be for the 3x. Okay? Or, Retina displays basically. So that's important to keep in mind, so you might want to keep that in mind as you're building your assets. I'm just going to use 1x for this project. So if we come back to our storyboard, now I want to add that background in here. So I'm just going to scroll this so I can see all the corners. And what we're going to do is we're going to search for image. And image view is what I want. So I'm going to drag an image view in here all the way at the top left. I'm going to drag that all the way down to the bottom right. Now before I go any further, I want to use auto layout to go ahead and set these constraints. So I'm going to, this might seem a little weird for a second, but I'm just going to lift this up a little bit because you need to be able to see what the options are here. So what all I really want to do is come into this section here, and just below what you can see, it says add missing constraints and then reset to suggested constraints. And we want to select everything, so just select this view controller and then just go ahead and reset to suggested constraints, and that adds a bunch of constraints to our project. Now we come back to the image view, and I'll just get this back down to normal. Then on the right hand side we can select the image BG that we put in. Now you notice a slight problem, and that is that the image is covering everything else. So how do we deal with that? Is we go to our outline here, and basically the way this is, inside this view, the view is everything you can see. We have a what if label, as you can see with the L, and a B for button, and then we have another label, and then we have this background image. And the background image needs to be dragged to the top of the view, basically. And then we'll be able to see our things. So now that we can see it, it looks like this is probably a little light, this label here. So we'll just make that a little bolder. Maybe we'll actually use a bold. I think if we use something like a bold, or maybe not a bold, semi-bold, would be pretty good. Hit done. You can see that much better. So this is going to be where our question is. Okay, but now basically we have our user interface laid out. What we need to do next is to connect this to the code view so we can start our coding, and that's what we're going to do in the next video. So now that we've basically designed our user interface, it's time to start connecting the code outlets to the user interface itself, so that we can code some functionality into this. So what we're going to do is we're going to head back into Xcode, and we're going to start connecting things, and we're going to start coding our project. Okay, so we got to start connecting these now, but there's one thing I noticed on this label here. So select this middle label, and we need to change this down to lines 0. Okay, because at line 0 what happens is this evaluates if it can fit into a current spot, and if it can't, it'll create a new line for the additional text. Okay, and because we don't know how long the strings are going to be that are going to go into here, we need to just be ready to go to additional lines. So we just set it to 0, and we don't have to worry about it now. So now to start connecting these, what we need to do is go to our assistant editor, and that'll bring up our main view controller, and I can get rid of the right side and the left side at this point. Oops, that wasn't what I wanted to do. I want that back. Get our assistant editor back. Get rid of that. And I also want to get rid of our left side completely. So now we can just bring in what we need. Now the what if is always going to remain what if, so we don't need to worry about that. But we do need to bring this label in, and we do need to bring this button in. So what we're going to do is just make a little bit of room at the top, and we'll bring our label in and make a reference to that. So if we control drag that, and since this is our only label, we can just name that label and connect it as an outlet. And that's all we need to put in there. Now, as I said, this is really just my kind of routine to put functions down at the bottom. But since our button is going to be a function, I control drag that down here below the other functions. Make sure we change that to an action. And we'll just call this what if tapped. And connect that as an action. And put a little bit of room in here for our function. Okay. Now, before we go any further, we need some data to work with. So we need some type of data source. And what we're going to use for that is going to be an array. So if you go into the resources for the class that you downloaded, and you go into the what if zip file, inside that what if zip file is a folder called what if, and inside that is something called main VC, which is what we're working on right now. And just copy the what if array out of there. So go ahead into the source, copy the what if array, and what we're going to do is we're going to paste that in right here so that we have a data array to work with. So now we have this what if array of data that we're going to use. And the first thing that we want to do is we're not going to worry about the sound or anything yet. What we're going to do is we're going to actually set the text for this label to change when the actual view is loaded. So we do that inside the view did load. So what I'm going to do is get rid of this comment here, and we're going to put our own code there instead. And all we really need to do here is say that our label text is going to be equal to whatever we want it to say when the program loads. So I'm going to say press the what if button or shake your phone. Because if we don't put anything there, then that will literally show up as label when the user looks at it, and that's not a real good experience. So now what we want to do is think about what we want to happen when they press the button. And one thing that we want to happen is we want them to be able to pull out a random string from this array. So how do we do that? Well, inside of our function, we can create a random number, basically. So I'm going to say let random, and I'm going to set that equal to an integer version of the arc for random, and this doesn't actually auto type, so it's arc for random underscore uniform. And then what we could do is just put a number in here, and that would be good. But we don't want to do it from a number. We actually want to do it from the what if array. So we need to cast this a little bit, because arc for random uniform expects a 32-bit unsigned integer, and don't worry about what that means. But we need to cast this as a u int 32. And then we want to come out of the what if array dot count. This way we pull out a random number that's always valid. This way our random number is coming from our what if array. Okay? So if we add more items or take items out, it doesn't matter, because our random number will be within the range that we need. Okay? Then the only other thing we want to do is we want to set our label dot text, and we want to set that equal to our what if array at the random index. Does that make sense? I hope so. So what's my error here? Unresolved identifier R. Okay, that's not actually an error. That's an Xcode build error. So what we do is we go up to product, and clean, and then product build, and that'll get rid of that. For some reason, Xcode jumbles up a little bit sometimes. Now, just as a reminder, I'm just going to put a reminder that we need to play the sound here. Okay, so we're going to put the code for the sound here, but we can actually see if our functionality works right now. So we'll play our, I'm on a 6 plus. Let me stop that. I want to go to a 6 like I was before, and we'll play that. 6 plus is a little big on my screen. So we're just waiting for this to come up. Now when it comes up, it should come up saying, there we go, press the what if button or shake your phone. So let's press our button. What if you could choose the way you die? How would you go? Interesting question. And it seems that we're getting random questions, so that's good. So now what we need to do is we need to work on the sound so that that happens. And we need to add shake detection to this so that instead of pressing the button, the user can just shake their phone to get another question. So we're going to do that in the upcoming videos. I'll see you in the next one. Okay, so at this point in the game, our app is pretty much done if you think about the basic functionality of it. So now what we're going to do is we're going to give it the ability to play a sound when a random question comes up. And we're also going to add the ability for shake detection, so the user doesn't have to actually press the button. They can just shake their phone and get a new question that way. So let's tackle that. We'll just head back over to Xcode. Okay, so we're going to tackle adding sound to this now. So the first thing that we really need, if you think about it, is a sound, literally. So I'm going to go to my desktop here, and on my desktop I have this file called beep.mp3, and I'm just going to drag this in here, and I'm going to say copy items if needed. This way it copies it to the project folder, and click finish. And now I have a sound inside here, but it's not actually quite that simple as anything. There's a lot of ways we could add this sound. So we're going to do it the somewhat correct way, and we're going to use a class file in order to do it. But there's a couple things that we need to do here in our main view controller. Let me get rid of this before we go ahead and import any type of sound functionality. And the first of which is to import AV Foundation so that we can work with audio. And we also want to become adherent to the delegate for an AV audio player. So we're going to say AV audio player delegate. So now we're compliant with that. Now we also need a variable for an audio player. So we're going to create that, and we'll just call that audio player. And that's going to be of the type AV audio player. And we're going to make that an optional. Okay. Now, by the way, that MP3 file is in the source code folder. If you didn't catch that, and you need to go back to the source code folder, because we're going to copy a function from our what if main VC Swift file in there. So the function that we're going to copy is the play sound function. Just copy that function out of there, and we're going to paste that into our view controller here, because explaining how to do the sound completely would just be too much overkill at this point anyhow. So we're going to use a function to help us do that. So I've copied the function. I'm just going to paste it down here in this open area. So if we take a look at this function, what it's asking for is a sound. So we don't have a sound class at this point, so that's what we're going to need to do, and I believe that's why we're getting this error, undeclared type sound. So we're going to just go ahead with that error for right now, but we're going to go ahead and create a class file for our sound. So if we come over here to what if, and we right click and we hit new file, and we want an iOS source, but this time we want to just do a Swift file, and we click next, and we're going to name this sound, and we're just going to save it right where it wants to save. So click create, and here's our sound file over here, and I'm just going to bring that right above or below our main VC. So this is where we're going to build our class for our sound. So let me just switch this to a single view. And I know we haven't gone over classes yet, but I wanted to introduce you to them early on because they are quite important. So the way you create a class is you say class, and then you give it a name with an uppercase letter, and this is going to be sound. And then we're not going to inherit from anything. We're just going to go ahead and open our class file up. Okay? And this is where we put the code for our class file. So what we're going to do is we're going to create a couple variables in here. One of them is going to be called file name. So we'll create that. And we're going to set that as of the type string. And we're going to create another variable for file extension. And that's also going to be a string. And now, in order to make a sound, we need to have an initializer on this. So we do that by saying init, and that's going to have a file name, which is going to be of the type string, and it's going to have a file extension, just like we declared above, which is also going to be a string. And aside from that, we're not going to do anything else. We'll just open that up, and inside here we're just going to say self.filename is equal to file name, and self.file extension is equal to file extension. And that's just basically saying that whatever the user puts in for file name, we're going to say that that's our file name variable up here. And whatever the user puts in for file extension, that's what we're going to use as the file extension. Okay, so we're actually going to create our variable for our sound right now. And we're going to do that just outside the class file, but within this same Swift file. And by doing that, we'll be able to access that from anywhere. So if we say let beep equal, and we're going to create a sound. So if we open up the initializer for that, then you'll see that it takes a string for the file name, which is beep, and it takes a string for the file extension, which is an MP3. Okay, so now we have a sound class and we have a sound variable called beep. Now all we need to do is actually call that sound function where we want to play the sound. And we want to do that in main VC right when we press our button. So above this sound file, right where we had our comment, right after that, we could go ahead and say play sound and put our beep variable in here. And now when we run it, it should go ahead and play that beep for us. So I have it running already somehow. I'm going to go ahead and hit play, and we'll see if this works. So we should get a beep. Okay, it is beeping on this side. It's really low. So I'm not sure if you can hear it, but it's working on my end. So that is our sound. And we get rid of this navigator. That is our sound, so that seems to be working okay. This was written to but never read. That's okay, you can leave it the way it is. And what we're going to do now is we're going to add motion detection. So this way, when a user shakes their phone, it'll play the sound and give them a new answer, and they don't have to hit the button. And we're going to do that in the next video, so I'll see you there. So we are almost done with the What If app. Just one more bit of functionality to add, that shake detection. And we're going to do that right now. So let's jump back into Xcode, and we'll give our app the ability to detect when the user has moved. Okay, so just one more final touch. We're going to add the ability to detect a shake. So what we're going to do is, just after our What If tapped function, we're going to add another function here. So just make some space there. And this is a built-in function. There's built-in functions in Swift and Xcode. And this one is called motion began. And we want the one with the event. And so the first one is there, motion began is the one we want. And in here, our code, literally all we need to do is call our What If tapped function. And we'll make our sender a UI event. And now, when the user shakes their phone, they'll get the answer. Actually, everything inside this function will run. So they'll get the answer, they'll get the sound, they'll get the whole deal. It'll just be like they pressed the button. So let's give that a test. So we'll play this. And you may be wondering how we're going to test this without it being on an actual device. But if you go to the hardware menu and you scroll down, you can select shake gesture, and you'll see that that goes ahead and simulates a shake, and that's working for our function. So everything seems to be in working order. I think a big round of congratulations for yourself for creating this app are due, and we're going to now take a look at some more Swift code. So we'll see you there. Hello and welcome to the iOS 9 iPhone and iPad app development course. In this lesson, we're going to be talking about Swift 2 optionals, binding, enumerations, and code safety. So let's take a look at what we're going to learn by the end of this lesson. First off, we're going to be able to understand what optionals are and when they are used. We're going to understand how to use optional binding to keep your code safe from crashes. We're going to understand what an enumeration is. And we're going to be able to handle errors using enumerations, error throwing functions, and switches. So let's get started. Okay, so in this video we're going to talk about optionals, specifically what they are and when they are used. So optionals are a variable that may have a value or may have no value at all. And an optional that has no value is expressed by returning a nil value. Now the reason that's important is because an unexpected nil value will crash your program. So it's important to understand how to properly handle them in your code. And we're going to go over a couple different ways to do that in the next couple videos. So at this point, we're going to jump into a playground. Playground is simply called optionals, and we're going to take a look at this. So in order to fully understand optionals, you first need to understand why you need to use an optional, or why you would use an optional, and also how to actually express that something is an optional when you create a variable. So we're going to do that now. We'll create a variable called temp. And when we do this, we need to specify the type. This is going to be a double. And then we put the question indicating that that's an optional. And you'll see that that automatically comes up nil on the right-hand side. Now, take note that writing this is the same thing as writing equals nil. But as you see on the right-hand side, there's no difference in that return. So at this point, you can use temperature in your program, but the interesting thing is if we actually try to pull temperature up right now, and we say the temp is, and we pull out the temp, you notice that it says the temp is nil. And since this is just a print line, it's not really going to do anything. But in a normal program, this nil is not expected, and it will crash the program. So whenever you see it is nil, and that /n is just a new line, but whenever you see is nil, then you know that in a regular program that's going to crash it. So how do we handle that? And the way we would handle that right now is we would use an if statement. And that's only because we don't know about if let and guard syntax. So we're going to use an if statement, and we're going to say if temp is not equal nil, then we would print the same thing. We would do the temperature is, and we would pull out temp, and then otherwise, so now we're going to say that we don't have a temperature, and we would do another print line, and here we would just say something like we could not retrieve the temperature. Okay, so this if statement is evaluating to our second else statement here, where it says the temperature could not be retrieved because we don't have a value for it. But let's say up here we did give it a value, and we go ahead and set temp equal to 32. We'll say 0.0 because it's a double. Then you'll see we still have another problem. And now these two statements both say the temperature is optional 32. So what we need to do is put an explanation point here, and that will explicitly unwrap or forcibly unwrap the variable for temperature. And if we do that here, you'll notice that that optional goes away also. But as we said before, if temp doesn't actually have a value, so if we were to comment that out, then you'll see that that first one crashes the program. And that's because it's not within an if statement. Now, this is showing what the old value was, but this is coming up as a bad instruction, and this will crash your program. So we can't use this if we assign it a value and pull it out, and we don't actually have a value there. So here we're expecting that it has a value, and it really doesn't, so it gave us that error. And here we're checking if it's nil, so this will never run unless it's not nil. And if it is nil, we've handled it here by running it like this. But there's actually better ways to handle this, and that's through the if let and the guard syntax. So in the next video, what we're going to do is we're going to talk about the if let and guard syntax, and we're actually going to do that here on this same playground. So we'll see in the next video where we talk about the if let and guard syntax. All right, we'll see you there. Okay, so now we're going to move on to optional binding, and we're going to learn how to use optional binding to eliminate app crashes. Now, optional binding is the process of associating an optional value with a value that's guaranteed to have a valid value. So when we do optional binding, it will never return a nil. Now we can do this using the if let syntax. we can ensure that an optional has a value before using it in our code. And likewise, if we're using a function, we can use the guard syntax, which will allow us to do the same thing, but within a function. So that's some pretty interesting stuff. We're going to learn all about optional binding, if-let, and guard syntax right now in a playground. We're using that same playground optionals, okay? So to completely understand optional binding, we really need to make sure you understand why you're using an optional. And in the example above, what we did is we created an optional called temperature, which is the type double, and we're not expecting to always be able to get the temperature because we might not be able to connect to the server that holds the temperature, or the thermometer might not be reporting to the server, or whatever the case, but we might not get a temperature back. So we need to account for that, and in that case what we do is we create an optional like we did here for temperature, and then here we actually gave it a value, but we still need to treat it as if it's an optional, because if it comes up as nil, then we need to know about it and we need to handle that. And one of the ways we can do that with optional binding is with the if-let syntax. So in this example, what we would say is if let temp2 equal temp, then we would go ahead and do our normal print line that we want to occur. Temperature is, and then we would just pull out temp 2 this time, which is our temporary variable, which doesn't get assigned a value unless temp has a valid value. So if we take this declaration that it's 32 degrees out of there, then you'll see that that example just does nothing. Now, if we'd like to, we can handle that fact that we have nothing there by kind of turning this, expanding this a little bit, and it almost looks exactly like an if-else statement, but you see the syntax is slightly different. And here we would just say that we could not connect to server. For the temperature. Okay, so there you see one way of handling it. That's through optional binding with the if-let syntax. So basically we're saying if we can assign, if we can let basically temperature 2 equal temp, and this is saying, and be sure temperature has a valid value, then we're going to print this statement out and use temp 2 because we know that has a valid value. Otherwise it won't do anything, and this else statement will pick it up and we'll print that out instead. So you can see how the if-let syntax can help you there. And I want to show you how a guard statement will help you do the same thing within a function. So in order to do this next example, what we're going to need to do is I'm going to create a dictionary. So I'm going to create a variable called states, and I'm going to set that equal to a dictionary of strings for the abbreviation and strings for the state name, the full state name. So I'm just going to put a couple in here. Say New Jersey, and we'll put in California. And the reason I'm choosing to use this as an example is because I want to query basically a dictionary within a function to return the state name from the abbreviation. And the reason we're doing that is because whenever you get something returned from a dictionary, it's always an optional because it doesn't know if that key exists yet. So we have the key of NJ, and if we look up the key of NJ, is what we're going to do, it should return New Jersey. But if it can't return New Jersey, then we're going to need to know about that. We want to handle that in our function. So we're going to now create a function, and I'm going to call this getState. And the getState function is going to take an abbreviation what we're going to call an abbreviation, and that's going to be a string. And this function is going to return a string as well. And we'll just open up our function block here. Now the first thing I want to do in the function is show you how the guard let actually works. So what I'm going to say is I'm going to say guard let state equal states, and then we're going to pull out dynamically that abbreviation that's given within the query, and then otherwise what we're going to do is we're going to go ahead and return the string state not found for abbreviation, and then we'll just go ahead and pull out that abbreviation again. Okay, so basically, let me get rid of that. What we're saying here is if we can let state equal states and then pull in that abbreviation, then we're good to go, and we're going to assign states that property or that value. And then otherwise, we're going to return the value state not found for abbreviation. We're going to return that string, but we still need to complete the function because we haven't actually returned anything that's a string inside this function yet. And in order for this to be a valid function, we need to go ahead and do that. So we would just go ahead and return the string that abbreviation is short for, and then we'll pull out state, and that will be our complete return for our function. So now when we go to call this, and let's say we call it with California, so if we call get state, and that needs a string, and we say CA, then it says California, or CA is short for California, and it would do the same thing as we said New Jersey, but let's do a state that's not there, like New York, NY, and you'll see state not found for abbreviation NY. So that's how the guard syntax can help you within a function to make sure that your code is completely safe and will not crash on you, because there's no way that this could ever evaluate to this return statement if this is never given a value. Okay, so that is optional binding with the if-let and the guard syntax, and you know, feel free to make your own little examples here before you move on, because we are moving on to something that's slightly different, which is enumerations. So we'll see you there. Okay, so in this section we're going to talk about enumerations. I'm going to give you a brief introduction, and we're going to go over the enumeration syntax. So an enumeration is basically a selection of items that are put into a list that can be selected. So using enumerations, we can limit the chance for errors by defining only valid selections. And enumerations have many uses, one of which is to be used with the new error handling feature in Swift, which we're not going to go over in this video, but we are going to go over in the following video. So what we're going to do is we're going to jump over into the enumerations playground and have a look at them. Okay, so as we said before, enumerations limit selections to make user and developer selections less error prone. So it's not only from the user's perspective that it makes things easier, it's really from the developer's perspective, and we use enumerations every day just while we're coding, and you may not realize it because sometimes it's called subscript, and it's basically the dot syntax that we use. So to give you a simple demonstration of that, I'm going to just import UIKit so we can access that framework. And let's say we had a keyboard and we wanted to set the type of keyboard. We would make a variable, or in this case a constant, that holds the value for our keyboard. So we could say keyboard type, and we can set that equal to a UI keyboard type. And here's where our enumeration comes in with this dot syntax. And what we're going to do is make this a phone pad. And then also along with that, I want to go ahead and make it dark. So I'm going to say let keyboard appearance, or keyboard style, we'll say, equal a UI keyboard appearance dot dark. And you see how there's really no way to get that wrong. If you want a dark keyboard, you can't really mess that up. Now, in addition to that, you can set other things like if someone has a favorite color, you could set favorite color equal to a UI color dot red color, for example. Right? And you'll see that color pop up on the right hand side. So how do we actually make one of these enumerations? Well, that's pretty easy. We start out with the enum keyword. So enum means enumeration. And the convention for naming an enumeration is to begin with the capitalized letter and then capitalize each word within the name of the enumeration. So in this case, if we imagine that we're making a appointment scheduler program, then we would have an enumeration for the day that the appointment was preferred to be held by the client. So in this case, I'm going to say appointment day, and then we're just going to open up our code block, and now we can put our enumeration in here. And our enumeration are going to be the days between Monday through Friday. So we make case statements, and one case here will be Monday. Then we could do Tuesday. But instead of doing it that way, there's a quicker way to do it. We can just back this up, and we can say Monday, and we can put commas in here. Tuesday, Wednesday, and so on. And all these will be counted as a separate case. So we're technically saying a case Monday, case Tuesday, Wednesday, Thursday, Friday. Okay, so now we have our enumeration done. Now to make an instance of that enumeration, basically, we're going to make a variable called day customer prefers. And we're going to make that of the type appointment day. And now there's a couple ways we could do this, and I'm going to show you one way that some people might do to begin with, is to put date customer prefers and then set that equal to appointment day dot Monday, for example. But that's a little redundant because we already said that day customer prefers is an enumeration of appointment day, so we could just back this up and just say dot Monday. Okay, and we also could have, when we said, we could have set this equal to appointment day dot Monday all on one line if we wanted to. Okay, but most of the time when you make an enumeration, you don't know the selection up front, so you don't do it that way. Now, the way that you're supposed to interact with these enumerations is using a switch statement. And basically what we would do is we would switch off the day customer prefers value. So we would do a switch statement off day customer prefers, and we'll just open up our switch and we'll put our case statements in. Now we're going to need a case for dot Monday, and now you'll see the syntax change, so the cases up above aren't exactly as the case below. So on Monday, we would just print a line and we would say customer prefers Monday. Okay, so what I'm actually going to do is just take this, and I spelled that wrong. So what we're going to do is we're going to take this here, and I'm just going to copy that for some of our other cases to make it a little quicker. So we're going to put a case here for Tuesday. Actually, it's got to be .Tuesday. And in that case, we're going to go ahead and print that line, but we're going to say Tuesday. And we need cases for .Wednesday. And we're just going to do that same print line, but we're going to change it to Wednesday. And I'm going to put a little room here. And we just have to put a couple more cases in here. Notice that it's giving us an error on this switch statement, and that's because the switch statement knows that we're dealing with something of the type appointment day. So it knows that there's 5 different appointment options. So until we have all those options in there, it's going to be an invalid switch statement. So let's put the final 2 in there. So we'll just put Thursday, and then we need one, just final one for Friday. Of course, we're not going to make any appointments on the weekend because we don't work on the weekend. Unless you do, then just make some additional cases. So this would be Friday. And now that we have all those cases in, you'll see that just by this being set as .Monday here, that the very first case here pops up and it says customer prefers Monday on the right hand side. Now if we change this from .Monday to .Friday, then it would go ahead and change to Friday. Okay, so that's a little bit about enumerations. That's how they're made. That's how they're used with switch statements. Now, in the next video, what I want to show you is how we actually use that all together with an error type and an error throwing function, and how we handle errors using the new Swift syntax for error handling. Okay, so we're going to be talking about enumerations, switches, and also error throwing functions in the next video. We'll see you there. Okay, so as we said in the last video, we're going to talk about error handling now. And we're going to be using enumerations, error throwing functions, and switches. But what do we mean when we say error handling? Well, error handling is the process by which we can limit potential errors and deal with them appropriately when the error is thrown. And in the process, enumerations are used to define probable errors, and error throwing functions can, what we say, throw an error defined on our enumeration if certain criteria are met. And we also use switches in the process, and they provide the basis for how the error is actually handled. Okay, so we're going to get into a playground right now, and this playground is actually called enum's error handling. So if you're looking for that in the source, that's what you're looking for. So we're going to jump right into that and talk a little bit about how to handle these errors in our code. Okay, so we're talking about error handling with enumerations and switches, and in order to demonstrate this, what I want to do is make a function that will log in a user to a database, and if the login credentials are correct, then there's no problem. Otherwise, then we're going to throw errors if the password's wrong or if the username is not located. So that's what we're going to do here, or actually if the username is not correct. So what we're going to do is we're going to set the actual passwords and username right now. So I'm just going to say let db username and we're going to set that equal to user, and then we're going to let db password equal password. Okay, now what we need to do is we need to make an enumeration of the type error type in order to handle these errors. So what I'm going to do is I'm going to make an enumeration with the enum keyword. I'm going to call this login failure. And that's going to be, as we said, of the type error type. Then we're just going to open up our enumeration. And we're going to put two cases in here. We're going to put a case for an invalid username. And a case for an invalid password. Okay, so now that we have that, what we're going to do is we're going to make an instantiation of this login error, this login failure enumeration rather. So we're going to call that login error. So we'll make a variable. We'll call that login error. And our login error is going to be equal to, or it's going to be, it's going to be equal to a login failure type. Okay, and we'll just set this as an invalid password to begin with. So now we're going to go ahead and make the actual function. Now remember, this is going to be a error throwing function, so we're going to have to use the throws keyword. We've gone over error throwing functions already, so this should be a refresher, or perhaps just more instruction on that. So if we make a function, and we'll call this login user, and that's going to take a couple arguments. One of them is going to be the username, which is going to be a string. Another is going to be the password, which is also going to be a string. Now, as we said, this is going to throw an error, so we'll use the throws keyword. Then we'll put our return arrow, and this is going to return a Boolean. And specifically, it's going to return a true Boolean if the user is able to log in. So the first thing we need to do is to check the database for the username. So the way we're going to do that is we're going to say guard username, and we're going to let that, if it's equal to, we're going to let that happen if it's equal to the DB username. Okay, otherwise, what we're going to do is we're going to set login error equal to a login failure dot invalid username. And then we also want to go ahead and throw the error. So we're going to throw the error login failure dot invalid username. Okay, so that's finished. Then what we want to do is check the actual password. So we're going to do the same thing basically. We're going to guard password. And if we can set that equal to the DB password, everything is good. Otherwise, then what we're going to do is we're going to make our login error equal to a login failure dot invalid password, and then we want to also go ahead and throw that error. So we're going to throw a login failure dot invalid password, and then if we can actually make it this far, so if we can get through these two guard statements, then we're going to return true, because if we can make it through them, then everything is correct and the user will be logged in. So now what we can do is we can go ahead and call this function, but remember, there's no guarantee that we're not going to get an error, because the username and password may be incorrect, and that's going to throw an error. So we need to go ahead and do this within a do, try, catch statement. So that's what we're going to do. So we're just going to make a do statement and open a code block. And within that, let me just make some room so you can see everything. We're going to go ahead and try to call the function. So we'll say try login user, and then we know we need a username, so we'll just call that user, and we need a password, and that'll be password. And you'll see on the right hand side it says true. Okay, so basically that's saying that with those credentials we're logged in, but we want to go ahead and do a print statement here, and we're just going to say login successful. Okay, now we didn't account for any errors yet, and then we do that here after our do, try, and now we're in the catch phase of our do, try, catch statement. So this is where we catch our errors. So what we're going to do is go off a switch statement here within the catch area, and let me just give it a little more room here so we can see what we're doing. So within here, what we're going to do is we're going to switch on the login error, and we're just going to make a couple cases here. So in the case that it's dot invalid username, then what we're going to do is we're going to go ahead and just do a print statement, and we're going to say login failed, invalid username. Okay, so now we're going to put our second case statement here, and you notice that we still have an error on our case here because we don't have all of our cases in yet. So the other one would be an invalid password. So if we put a case for that, and we're going to go ahead and put a print line in there, and we're basically do what we just did, but we're going to print that login failed, invalid password. Okay, so now you can see that based on what we've put in, when we have the correct credentials, we have the user and password, and that's what we had declared up here, that's going to be our username and our password. So we have user and password, and that's put in correctly, and you see it says login successful and true. But if we put password to be something like just pass, then that will switch. It'll no longer say true, and it'll also say down here in our catch statement within our switch, it'll say login failed, invalid password. So it'll give us the reason. So this is the basic way that you're supposed to handle errors within Swift using enumerations and switches and error throwing functions. And it may be a lot to take in, but it's actually pretty simple if you look at it and you study it and you perhaps try to just make yours on your own. It's a little easier to grasp if you try to put this into. I use the username and password thing because it's easier for people to understand and grasp, but you can make a different type of system, you know, like some banking thing or something, and make your own error types. And I suggest that you do that to go ahead and become more familiar with error handling. Okay, so that's it for this video.